Hello, in this presentation I'm going to talk about a very important topic, which is inheritance. Now we've actually been using inheritance since the very first class, but now we're actually going to look at it in depth and use it in ourselves to make new objects. So what is inheritance? Why is it such a big deal? Well, C#, like other object-oriented languages, allows you to use existing objects as the foundation to build new objects. You can take an existing class and make a new class that reuses an existing class and gets all the properties of that class. And when you do that, the new class is said to be the derived class or the subclass, and the class that exists already that you're kind of taking advantage of and building on top of and using your foundation, that's called the base class. Let's take a look at this example here. So a text box, a label, and a combo box, those are all different types of controls, and they all inherit from a base class called control. So a text box, a label, a combo box all have a lot of properties in common. They have a text property, a coordinate on the screen, maybe a size, maybe a font. They all have that because they inherit control, the control class, which has all of those properties. So all of those classes, text box, label, combo box, those are derived classes, and in this example the control is the base class. And we'll talk about polymorphism in a second. Now what's going on here, the major advantage of all this is that rather than having position and font and text all duplicated in each one of these controls, I can just put that all into a common object and then make different new objects that inherit those properties. So what inheritance allows you to do is reuse existing code and also treat different types of objects as though they're the same type of object. That's what polymorphism is. So a text box, a label, and a combo box, those are all controls. They're all types of controls. And they all share common properties because all of those common properties are inherited from that base class, the common base class, which in this case is control. So everything that we've used in the C# language actually inherits from system.object. So system.object is the base class for everything in the C# language or in the .NET framework, and it has four functions built into it: equals, get hashcode, get type, and toString. So every object that we've ever used in the .NET framework has had those four methods or those four functions built into it because they all inherit system.object. Either directly or indirectly. You can have many layers of inheritance, and that's why every object in the .NET framework will have these four methods because they're inherited from the base class, which is system.object. So if you type object, and you use the IntelliSense, and you'll see like what does an object have in it, you'll see that it's got those four methods, and since everything in the .NET framework inherits system.object, everything in the .NET framework has these four functions. So what does that look like syntactically? Well, we've seen this from day one. If you make a class, and we'll just type class, base class, and then we'll assume that it has some functions in it and some variables, and we want to make a new class that uses base class. So this is base class is going to be the existing class, and then we're going to make a new class called derived class that inherits the base class and sucks up all of its properties. Well, the syntax for that is to use the colon. So in this example here, you can see we're making a new class called derived class, and then we say colon base class. So this means I'm making a new class that uses an existing class, and we've seen this over and over again with the forms, right? So I make a class called form1, and it says colon form. So all of any forms that we make, they have all these properties. Where are those properties? We didn't add them. They're all in the base class. They're all in the form class. So syntactically, that's how you make a new class that defines or that reuses an existing class. A derived class is the superclass or the subclass, and the base class here is the base class. All right. So our new class, derived class, will have everything the base class has. It is built on top of the base class and then inherits everything that it has. You can only have one base class. C++ does allow multiple inheritance. You can't have more than one base class. However, I have never seen a textbook that actually showed you how to do this. Every textbook I've ever seen says multiple inheritance is a terrible idea and you should never use it and we're never going to talk about it. So, and many other languages realized that multiple inheritance can create a lot of problems, and they removed that feature from the language. So Java does not support multiple inheritance, and C# does not support multiple inheritance. If you need an object to be more than one type of thing, that is where interfaces come in, and I'm going to talk about interfaces in a later presentation. So if you need something that's both an alarm and a clock, you can't have a base class called alarm and another base class called clock. You can't have two base classes. You can only have one. However, you can get around that using interfaces, because you can inherit, or you can implement as many interfaces as you want. Interfaces are a way around the limitation of only being able to have one base class. Now, when you inherit an existing class, what the new class has access to in the existing class depends on the access modifiers in the existing class. So we need to talk about access modifiers. So public, private, and protected. So these, again, C++ and Java both have these. So if something is public in a class and you inherit that, you can still see it, right? So it's available. Anything that's public is available to the outside world, and it's also available to any new class that you build on top of that class. So public stuff is available to new classes that may inherit or subclass an existing object. So if something is public in a class and you inherit that class, you can see that stuff. It's public, right? Anybody can see it because it's the whole world can see it. If something is private, private stuff is just for internal state keeping only. So if you make a new class on top of an existing class, you can't see anything in the existing class, or you can't see anything in the base class that was kept private. So private stuff is not available it's not visible to the outside world, and it's not visible to subclasses. And that can be a little bit of a nuisance when you design your classes. I find private to be a little bit restrictive. There is a middle ground, though. All right, so I should have mentioned this. Yes, if you don't put an access modifier on something, it is private by default. And I already said all that. Okay, so protected. Protected is the middle ground between public and private. So protected stuff is not visible to the outside world. You can't call an object's protected functions, but subclasses, new objects, can use the protected attributes, properties, functions in their base classes. So if something is protected, it means it's accessible by subclasses, by new objects, but it's still not really public. It's sort of halfway between public and private. I don't really use private a lot. I use public and protected most of the time. All right, so we have to talk about constructors now. A constructor is that special function that builds an object when it's created. And when you have inheritance, you have objects built on top of objects, built on top of objects, built on top of other objects. It is very important that the constructors be called in a particular order. So imagine you're trying to build a skyscraper here and you try to build the top floor first. Bad things are going to happen. You need to build the lowest level object first, right? You need to build your base classes and then build the new classes on top of that. So imagine your base class has a list and your derived classes or your new classes put stuff into the list. The list has to exist first before the new classes can use it, right? That is why objects have to be built from the bottom up. So how do you make sure that objects are built from the bottom up? So let's talk about that. So how do we, I mean, one way of calling this is constructor chaining, right? How do you chain these constructors together so that every object calls the constructor in its base class so that the base class gets built first? And we've talked about this with respect to classes. If a class doesn't have a constructor, the compiler will sneak one in that does not take any parameters. You need to have when you make an object, you need to make sure that one of its base class constructors is getting called. And if there's no appropriate base class constructor to call, you'll get a compile error. Let's take a look at how this works here. So now remember, when you make when you make a class, if you don't put in a constructor, the compiler will sneak one in for you. And in this example here, we've got two classes. We've got an object called base class. There's base class, and notice it has a constructor, and its constructor says I'm in the base class. I'm in the base class constructor. And then we're going to make a derived class here. And notice the derived class is built on top of or inherits the base class. And the derived class has a constructor too. So what's going to happen is when the derived class is created, the constructor will actually call the base class constructor. So the base class's constructor will run before the derived class's constructor will run. I know that this is getting kind of confusing, but I'm going to show you here what it would look like on the command line so you can see what's going on. What's going on here is that the compiler is sneaking in some code for you. It's sneaking in a call to the base class constructor, so the base class gets built first before the derived class does. So if we actually run this, you'll see it says in base class constructor, and then it will print out in the derived class constructor, right? The objects got built from the bottom up. So this derived class constructor, it actually snuck in a call to the base class constructor here. And so the base class constructor actually ran before the derived class constructor. And that's so the objects get built from the bottom up. Now, if we didn't have this constructor here that didn't take any parameters, like we had another constructor that took like 3 parameters or something, then the compiler doesn't create a default constructor for us. So in that case, the derived class wouldn't know what constructor to call in the base class, and you get a compile error. So how does this, what does this look like explicitly? Let's take a look at some examples where we have to actually pass parameters down to our base class constructor, and then you'll see exactly what's going on with the compiler kind of sneaking in calls to the base class constructor. So imagine I've got a base class here, and it has a constructor that takes 2 parameters. So that's the only constructor this thing has. It has a constructor that takes in 2 parameters. And now we're going to make a new class called derived thing that uses the base class. So this syntax right here is the mechanism for calling the base class constructor. When you say :base, this means call the constructor in my base class. And this call, this base xy, will run before the code in the constructor itself. So when this derived thing constructor is called, it says, oh wait, I can't run my code yet, I have to call my base class's constructor. Now if that base class had a constructor, it would do the same thing, and it would say, okay, hang on, wait, I have to call my base class's constructor before I can run my code. And it would get all the way down to system.object and then system.object would say, okay, I'm all done, right? And then the function, the constructor calls start returning, and then the object will get built from the bottom up. So this is the mechanism for calling the constructor in your base class and passing in parameters. So that is an example of how constructors, an object can explicitly call a constructor in its base class. So it's just after the function signature, you just say :base, and then you pass in whatever parameters you want. So this is an example of we're taking the parameters that are used to make this object, and we're passing them down to our base class, so it can have kind of first dibs on them. All right, so back to polymorphism and inheritance. So one of the major advantages of inheritance is that we get to reuse code. If and think back to the controls. Like all controls have a lot of stuff in common, right? So rather than duplicate that in the hundreds of types of controls there are, just put it in one common control class, and then everybody can inherit it and then get access to that stuff. Now, like the text property in a text box is different from a text property in a label, right? So sometimes we need to redefine the behaviors in those existing objects. So how do we do that? How do we override or replace the implementation that may exist in a base class when we make a new subclass or we make a new derived class? How do we override or replace, re-implement a behavior? So that is called overriding. When you replace the implementation in a base class with a new one or a specialized implementation, that is called overriding. And if you want to override a function in the base class, it has to be marked virtual. Virtual means I allow other people to come and redefine this function. So virtual means a function has to be virtual in order for you to override it. When you actually provide the new implementation, you have to use the word override. So virtual and override get used in pairs. If something is virtual in the base class, you have the option to override it in a subclass, in a new class, in a derived class. So we'll take a look at that. So in this slide here, I've got a class called mammal. All right, so mammal is kind of like an abstract object. It's just kind of a concept. You can't see a mammal. You can't feed a mammal. You can only feed a type of mammal. It's a concept. It's an abstract idea. And in here, I've defined a function called speak, and it is public, so anybody can use it. But the fact that it has been marked virtual means that other classes can be built on top of mammal and redefine the speak function. So if I make a class called my dog, right, and it inherits mammal, I get the speak function because through inheritance, right? You inherit everything in your base class, and if I don't override it, if I don't redefine it, I'm just going to get I make a dog and I call it speak function. It's just going to say I'm just a concept, I don't talk, right? Which doesn't make a whole lot of sense. So in the dog class, how do we provide a speak function that overrides the one in mammal, right? We like everything that's in mammal. Like mammal's got like the right number of legs and the right, it's got hair and fur or whatever. It's got all these properties that we maybe it's got a genus and a species and a kingdom and a phylum, or I don't know, whatever. But it's got all of this stuff, and most of it, 99% of it, is good, and we don't need to change it. But there's just a little bit that we need to redefine. So how do we do that? That's where we use the word override. Remember, virtual and override are used together. They go in pairs. So if I want to provide a speak function in the dog class, or in the my dog class, I use the word override, right? A public override void speak. This means I am replacing the speak function in my base class. So public override speak, and then I'm replacing it with a new version that says bark, 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 bark. And I should probably put in something at 4 in the morning because my dog likes to do that. So that's an example of how do you use virtual and override. They're going to be used kind of in pairs or in tandem. You can't override a function unless it was declared virtual in the base class. So there's an example of how to use virtual and override. They go together. They're used in pairs. Did we have to override the speak function? No, of course not. If we didn't override the speak function, we would get the default behavior, the default implementation in the base class. Most of the time, that's good enough. But if something is virtual, that allows you to redefine things that you need to provide specific or specialized behaviors for. Now, some interesting things about access modifiers. If something is marked public, basically you can't mess with access modifiers because it kind of breaks an object's interface. And if you take an object that you can't you can't override a public method and make it private, because you're kind of removing that function from the object. And if something is private, you can't make it public, because now you're kind of unlocking an object that was kind of meant to be locked, or you're exposing something that was meant to be exposed. So you can't change the access modifiers on functions when you are overriding them, because it breaks the object's interface. And a base class is really kind of a contract that you have that you implement some certain functions, and that all subclasses should provide at least that same interface. So that's why you can't remove functions from a class or by hiding them using private. It would break the object's interface. And then if you could take private stuff and redefine it to be public, well, that's a security risk, right? Because now you could go into the vending machine and steal all the candy bars, or so you're not allowed to change access modifiers, right? So let's talk again about polymorphism. So imagine that we have a mammal class, and then we make some new classes that inherit mammal. Cow, dog, and horse are all mammals. Remember that ISA and ASA, those keywords. A cow is a mammal, right? It is a specialized type of mammal, and it can be expected to have everything in it that a mammal has. Whatever interface, whatever public functions a mammal has, a cow is guaranteed to have those too. Same thing with the dog, same thing with the horse. A cow, a dog, and a horse are all mammals, just like a text box, a label, a combo box are all types of controls. And if they all have that same set of public functions, then we should be able to treat them as they're all the same type of object. That's what polymorphism is. You can treat many things as though they're the same type of thing. Right, so that's what this slide is all about here, right? So a cow is a mammal, a dog is a mammal, a horse is a mammal. Like, I've been asked that on interviews. What's the difference between an ISA relationship and a HASA relationship? And an ISA relationship refers to inheritance. Like a dog is a mammal because it can be expected to have all of the properties that a mammal has through inheritance. Has a relationship that refers to containment, like maybe a mammal has a tail or something. I don't know. That refers to containment, but ISA refers to inheritance. And then I know I've said this before already, because I just kind of like polymorphism. Because if objects all implement the same interface, you can treat them as though they're the same type. You can all treat them as though they're instances of that common object. So I can make a list of mammals, and then I can add a cow, dog, and a horse to that list of mammals. Is a cow a mammal? Yeah, it is, through inheritance. Is a dog a mammal? Yeah, sure it is, through inheritance. Same thing with the horse. I can even make a variable called mammal M, and I could say equals new cow, and that works because a cow is a mammal, right? So this is an example of polymorphism. I can treat many different types of things as though they're a common base class, as though they're a common type. Now, if I loop through this list, what would happen? Well, assuming that I've overridden all of the speak functions to provide specialized implementations, I would get the specialized implementations. I would get woof, cow, or bark, 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 bark at 4 in the morning, and moo and neigh, or whatever it is that the animals all say, right? So this is called dynamic binding, and what that means is the implementation that you get is determined at runtime rather than at compile time. So in our compile time, we know that list is of mammals, but at runtime, we get the right implementation. The implementation we get is determined dynamically at runtime rather than statically at compile time, based on what the compiler can identify as the type, right? It's based on the type of object in the list rather than the type that the list was actually defined to contain. Right, so the fact that you get the right implementation at runtime is kind of why it's dynamic. It's called dynamic binding versus static binding. Dynamic binding works at runtime. Static binding happens at compile time. And I've never really seen examples of static things going wrong. I guess I've never seen an example of static binding that I know about. But in Java and C++, you'll get dynamic binding as well. So some other words that kind of creep in to the vocabulary. when we're working with inheritance and virtual, defining base classes and redefining or overriding functions, is the word abstract. So remember that the mammal we created. A mammal isn't really something that we should be able to create. We shouldn't really be able to create a mammal. So we could mark that class abstract. And abstract means you can't instantiate it using the new operator. An abstract class has to be subclassed. You have to make a specialized implementation of it and then create that using the new operator. So if we had made our mammal class abstract, we couldn't actually make a mammal. We would have to make a class that inherited mammal. So an abstract class is kind of like a partial implementation that you have to complete. You can think about it that way. So here's what our mammal would look like if we made it abstract. So classes can be abstract and functions can be abstract. So an abstract function is it's like saying, okay, my subclass, any object that is a subclass of me has to provide this function. So the mammal class says, you know what, I have to have a say something function, or I have to have a speak function, or whatever, but I'm not even going to provide a body. I'm not going to provide any implementation at all. I'm just going to say this function is abstract. And that means that anybody who subclasses me has to provide actually provide the function implementation, has to provide that function. And if a function, or if a class has an abstract function in it, like this class does, the whole class has to be abstract, because what you're saying is if this thing doesn't have a body, it's not a complete implementation. If the class isn't complete and is leaving work for somebody else to do, then you can't make the thing abstract, or you can't actually instantiate the thing, so the whole class becomes abstract. Basically, if the class contains anything abstract, the whole class has to be marked abstract, because it's an incomplete implementation. All right, so how do you complete the implementation? You have to make a subclass, right? So down here we're going to make a new class called cow. It inherits mammal, and in here we're going to provide an implementation for the say something function, or I should have just called it speak. So now we have a complete implementation because we provided the say something function, and now we can actually go make cows, right? So when you make something abstract, it's just kind of a partial class that's there for you to build on. It's kind of like a starting point, but you can't actually use it until you go complete the implementation. There we go. Yes, so I already said this. So my say something function does not have a body. That's what makes it abstract. It's just it's saying, you know what, anybody else who subclasses me has got to provide an implementation for that. And I already said that too. So if the class contains anything abstract, the whole class has to be abstract because it's incomplete. The class is incomplete. If you don't want a class to be derived or subclassed, you can mark that it is sealed. This is the Java keyword final. So imagine the math class, right? You don't want to redefine like the POW function or the square root function or any of the functions, or the absolute value function, right? Like those are not things that are subject to interpretation, right? It's like, okay, these things are good, they're tested, they're done. Now we're sealing this thing, so no one can come along and redefine what the square root function does. That just doesn't make any sense. So if you look at the math class, you'll see that it is sealed. You cannot inherit the math class, add new stuff to it, or redefine any existing stuff in it. So that's what sealed means. And then this is going to start getting us into interfaces, which are also very important in C#. But I'm going to talk about interfaces kind of exhaustively in a separate presentation. But an interface, I'm mentioning it here because an interface is very similar to an abstract class. It is really the specification rather than an implementation. An interface is really just a list of functions that you agreed to implement. That is what it is. Just like if you inherit an abstract class, you have to implement any of the abstract members. If you implement an interface, you have to provide implementations for any functions in that interface. So an interface is very similar to an abstract class, except interfaces have some restrictions on them. They don't contain the following things: implementations, constants, anything static, or constructors. So an interface is really just a list of functions. And they're very useful because you can sidestep around the limit on multiple inheritance. You can implement as many interfaces as you want. But I'm going to talk about interfaces more in another video. So if here's an interface, and it's called iAnimal because that's the convention for interfaces start with a capital I. I've got a function here called say something, and notice it doesn't have a body, right? So this is very, very similar to an abstract class. And if you actually go into C++ and you look at C++ as interfaces, if you look up the term, if you kind of drill down through the documents, looking for interface, like where do you find the word interface? When you get to the very bottom, it's actually like pound defined to be an abstract class. An interface is really just is a purely abstract class that is no implementations in it at all. It just has a list of functions that an object agrees to implement. It's a contract. But I'm going to talk more about interfaces later. So in this here, what I'm doing is I'm making a dog, right? And the dog implements the iAnimal interface. Again, that's very much like that's the syntax for inheritance, right? And then I'm providing a function. I'm providing a body for the function that I said I was going to implement, right? So iAnimal says you have to have a say something function. So okay, there, I'm providing it. The only difference is you don't have the word override. Okay, so interfaces and abstract classes are very similar. The difference is you can only have one base class, but you can implement as many interfaces as you want, and I'll talk about interfaces in a separate video. And I think I already talked about sealed. Okay, so we've already done this runtime type checking. You can type or you can test at runtime whether something is part of a hierarchy or not. You can test what type of object it is. You can test if somebody gives you an object. You can test is it a dog? Is it a mammal? That's the is keyword, right? You can type check at runtime. So here I've got a mammal. Maybe I've got a list of mammals, and I pull the first one out. Can I see if it's a dog? Yeah, I can say if M is dog, right? So if that condition is true, then I can do something dog specific to it. And we've talked about is and as before, but that allows you to type check at runtime. That's your dynamic cast, right? And then as will cast an object to a new type. If the cast fails, the result is null. So rather than having the cast blow up and crash, it will fail gracefully. So is and as are just ways of doing type checking at runtime. So if I have a mammal and I can kind of gracefully cast it to a dog and then test the result. That's your dynamic cast operator in C++. All right. If you're doing a lot of is and as, you might be doing something wrong because you shouldn't really have to care what specific type of something is. You should be kind of having polymorphic behavior where you're treating all objects the same, and you're treating them all like a common base class. Like we should be treating our stuff all. If we have a list of controls, we should just be able to treat them all like controls, even if they're combo box labels, lists, menus, whatever. So, although I don't think menus are controls. So, if you're using is and as a lot, I might take a closer look at that. And that's it. So, I know that was a lot. So, inheritance, very, very powerful. It allows you to reuse code and share behaviors, and that keeps your code base smaller and much, much more reliable. So, there you go. There's inheritance. I hope that was useful. In the next video, I will talk about interfaces, which share a lot in common with abstract classes.